Well, the FIVOX and USGS team, thought that there will be a real Lahar problem because it was very clear to us that Pinatubo eruptions were characterized by large volume pyroclastic flows, which are the source of Lahars. Plus the fact that communities downstream are built on widespread Lahar deposits. So there should be no other conclusion that after the eruption or immediately after the eruption, we will have a problem with Lahars. I'll use the same maps shown by Chris earlier. He mentioned pyroclastic flows, but please note that in the earliest map, the only thing that we did was to outline where the Lahar channels would go. We actually missed one big Lahar drainage system over here because we didn't have any idea of where the pyroclastic flow would go. But essentially, the maps were used for evacuation and disaster response activities. Let me deviate a little bit to explain to you the Disaster Coordinating Council network or systems in the Philippines, which is very similar to Italy also, but there are minor deviations. At the national level, we have what we call the National Disaster Coordinating Council. Then, we change it now to National Disaster Risk Reduction and Management Council. But essentially, the composition would be ministers or secretaries of national departments, and our mother agency called the Department of Science and Technology is part of it. So we are part of a National Disaster Coordinating Council because we are a warning organization. There are many organizations involved, so we deal directly with them. From the national level, we have Regional Disaster Coordinating Councils. And please take note, the executive arm and coordinating body of these councils would be the Office of Civil Defense. The Office of Civil Defense is headed by the National Director, and for every region, 13 regions in the Philippines, we have Regional Office of Civil Defense. At the province or state level, we don't have any civil defense, but we have the chair of the Disaster Coordinating Council as the governor of the province. Down the line, the city or town would be the mayor. And down to the lowest level of governance called the village or barangay, we have the captain. However, since the Office of Civil Defense did not have any member down at the provincial level or the town level, what they have done is to have a disaster or civil defense coordinator at the provincial and local level, hence ensuring the sustainability of actions even though that the politicians, governors, would have elections every 3 years, up to 3 terms they would have, but sometimes they would not win. So we have to ensure sustainability and make sure that somebody is responsible for dealing with disasters, even though the politicians are also busy in some form or another. For the information and warning flow, for example, for eruptions, we at FIVOC's main office would deal with the National Office of Civil Defense. Those stationed together with USGS at the Clark Air Base would deal with the Regional Disaster Coordinating Council. For most volcanoes, only one governor would be covered. And so we deal directly with the governor. But Pinatubo covers 3 major provinces. So we course through the information through the Regional Disaster Coordinating Council. We have an advanced force in Zambales, northwest of the volcano, and since they're closer, they deal with the Provincial Disaster Coordinating Council of Zambales, a big province. From the Regional Disaster Coordinating Council, Office of Civil Defense, Region 3, they would deal with cities and provinces. In the Philippines, we have chartered cities. Although they are part of the province, they are not politically under the control of the province, so they would have to be dealt with separately. And the provinces and cities would now go to the different villages and towns, okay? So that's the flow of information. And the different local governments would now bring the information down to the public. Not shown will be the media, okay, which are important partners during the eruption. For Lahars, however, we recommended that the warning for Lahars will be done by the local government. And there were simply 3 alert levels for Lahar. Alerts level 1, 2, and 3, meaning get ready, get set, and go. Essentially, when there is a typhoon forecast, when they will get ready, And if there are heavy rains in the area, that's alert level 2. And when they see that there is a coming lahar in their area from the watch points at the upper level, then they would say alert level 3. Of course, later on, we found out that there were false alarms because please note that the lahar would go down 30 to 40 kilometers from the crater. And so maybe the lahars affected the middle part of the channel, but it did not go down to the farthest level where most communities are located. So people thought that these were false alarms. Now, during the eruption, it was very clear to us that the threat of post-eruption lahars would be a bigger problem. As Chris mentioned, the climatic eruptions deposited a lot of pyroclastic flows on the slopes of the volcano. This is taken from Clark Air Base. Around 5.5 cubic kilometers of pyroclastic materials were deposited on the slopes, and these affected down slopes 16 kilometers from the summit, covering an area of 400 square kilometers. Aside from that, tremendous amount of ash, up to 3 cubic kilometers, were scattered all over and would be a temporary source for succeeding lahar events. We also thought that old pre-1991 eruption materials would also be partly remobilized by succeeding lahar flows. So it's very clear for us that there will be problems. Let me illustrate to you the tremendous impact of the pyroclastic flows. This is Marero River at the southwest slope of the volcano prior to the eruption. This is the river, and this is a peak with a red star. Immediately after the eruption, the whole valley was filled down to 200 meters thick, and this will become major source of lahar events. And these are all over the slopes of the volcano. 3 years after the eruption, you would see that these same area are now very eroded, meaning large amounts of materials were already eroded and conveyed down the channel as lahars. Okay. We also need to worry about asphalt-covered slopes. Unlike rivers draining the pyroclastic flow fans, which would have longer-term lahar problems, we will have immediate but temporary problems for slopes covered with asphalt. You know that the Philippines is a tropical country, but if you were there, and I was there on the ground during the climatic phase of the eruption, you would feel that you were in a winterland because the ash deposits were white, like snow. And so in this river, we thought that there will be lahar events also in this river, which would be sourced from the asphalt draining the slopes of the volcano. So we have a problem. For some rivers, not a big problem because these will be temporary, but many people are downstream. But we will have bigger problems for those draining pyroclastic flow fans. So the major questions that the FIVOX USGS team asked about lahar risk is, first, how big is the lahar problem? And to do that, we have to really estimate the volume of pyroclastic materials deposited on the slopes of the volcano. Second is, if it's big, how long will the problem last? How many years? Because the intervention will depend on this. And to prioritize the intervention, the next question is, what areas will be at greatest risk? Okay? So we try to answer this. For the magnitude of the problem and the length of the problem, a joint FIVOX and USGS team projected lahar volumes that will be conveyed through time for planning intervention. This is the overall summary for the whole volcano, but we have this per river system. Essentially, the largest volume would be right after the eruption, and with time, since you are decreasing the available source materials, then we expect that the amounts per year would also decrease. So essentially, the estimated volume would range from 1 to around 2.5 billion cubic meters of ash will be eroded in the next 10 years after the eruption. So essentially, that was followed by the volcano in terms of the lahar events. Again, rivers draining the asphalt-covered slopes will have a short-term problem. So we didn't really worry much about those drainages for a long term, but rivers draining pyroclastic flow fields will have long-term Lahar problems. The team prepared a hazard map, and this is like a couple of years after. This is the pyroclastic flow deposit, and these are the major river systems where Lahars would flow through. Please note that those major river systems draining the pyroclastic flow would have long-term problems. However, several years after, there were secondary explosions on the slopes of some of this pyroclastic flow that changed the course or the risk of Lahars in some areas. For example, this river draining the southern end of Clark Air Base was cut off from the main source of the pyroclastic flow because of a secondary explosion. Several years after, this major river was cut off from the main source because of a very big secondary explosions that transferred all the possible Lahars to this river. So, in essence, scientists need to be actively monitoring the event, not only during eruption, but also during major Lahar problems because of the dynamism of the problem. These two big river systems in the western side of the volcano would have a very long-term problem, but this river and this one, because they are only draining asphalt-covered slopes, would have problems like maybe within 2 or 3 years only. So we have identified the highest risk areas. So those are the major areas that we prioritized in conducting awareness campaigns and also doing interventions. Let me show you first, before I discuss the interventions by the civil defense authorities and the national government, the different Lahar impacts so that you would understand the scenarios that we were facing immediately after the eruption. Lahars destroyed roads and bridges. And this one was right after, during the, well, actually within the eruption phase. Okay, this is near Angeles City, near Clark Air Base. A bridge was destroyed and roads were destroyed. And you cannot imagine that a single event can bury rivers 10 meters thick of debris. This is a house near the river, 10 meters high, and just an overnight rainfall because of a typhoon, this was covered. Communities were buried. This was before the Lahar and the Lahar after. In this case, though, the culprit was not directly the Lahars draining the slopes of the pyroclastic flow, but previous Lahars dammed a tributary, and the tributary stored a lot of water. And when the Lahar debris dam was overtopped, it got eroded, and a big rush of water moved down, and it happened like very clear day. So people were caught unaware, and many people died because of this. A long-term effect of Lahar depositions in many parts of low-lying slopes of Pinatubo would be siltation causing shallowing of rivers, trapping the water upstream, causing backflooding, and for the perennially flooded areas, the problem worsened. So in essence, we still have this problem 20 years after the eruption. So the Pinatubo landscape in 1995, this is a NASA taken photograph. So this is the pyroclastic flow and the major rivers. So only 5 major drainages were identified as problems for Lahars. And by that time, more than 2 billion cubic meters of 1991 deposits were remobilized. And the Lahars buried 400 square kilometers of lowland areas and displaced 50,000 people, or around 10,000 families. It was really a long-lasting and a big problem. So what were the mitigation decisions? Of course, the obvious thing is to prevent or direct the flow of the Lahar. So the engineering interventions were to dredge the channels and to build dikes. But actually, there was a big debate. scientifically and politically, whether we need to protect all communities or sacrifice some which are not affected yet by lahars. Of course, politicians, which would cover areas that can be sacrificed, resisted. And people even, of course, resisted because they will be displaced. And that's a common reaction by the society. So what happened was dikes, or earthen dikes, were initially built beside river channels, but later on, distances between dikes were widened. It's very obvious. For scientists, the dikes were so narrow. But because of the problem of the sacrificial communities and a big debate about it, this was not pursued by the engineering community. But later on, people got convinced because of the lahars coming every year and affecting more and more areas, then they get finally convinced that we need to have a wider dike system. There were also problems of the right-of-way for several locations. But the reality is, engineering intervention cannot be done overnight, and this must be done by phases. And please take note that nature or the lahar events work faster than man in terms of construction, in terms of dredging. So even maybe the best country cannot outbox or outmatch nature in case of Pinatubo due to the magnitude of the problem. Second decision is to resettle, transfer families and communities to safer areas. We need to consider the different housing types. There must be livelihood that must be provided to people because they are farmers or indigenous people, so they need to at least earn a living. And we have to be sensitive to cultural attitudes because we have many indigenous people living on the slopes. You cannot just bring them down to low-lying areas, so they preferred staying in the hills. Okay. The third is for those who don't want to be relocated or communities that they didn't agree to be relocated, and for those areas that can be warned, of course, the third option is to conduct lahar monitoring and warning. And monitoring was done mainly through lahar manned watch points upstream of rivers, through the various local disaster coordinating councils up to the regional disaster coordinating councils. And the watch points are manned by police or villagers that would have two-way radio, and when they see something, they would report and warn the residents downstream. And the warning system was augmented by rain gauges and acoustic flow sensors from USGS. We don't give the direct warning, we give the data to the Regional Disaster Coordinating Council, which will then pass on the information to the different towns. Lastly, the government also decided that because of the initial impact of the eruption and the succeeding problems for Lahar, a bigger body to coordinate beyond the Office of Civil Defense would be needed to handle recovery of the Pinatubo affected area, including engineering intervention, relocation, and livelihood. And they called it the Mount Pinatubo Commission. One of the big projects that they did was to build a mega dike at the southwest slope of Pinatubo to protect the biggest city in Central Luzon, okay? And it cost like $200 million. Okay, so the intervention was very costly. Aside from that, we need to make sure that people are educated. We conducted a lot of awareness and preparedness campaigns. So aside from the video presentation of volcanic hazards produced by Maurice Kraft, which was very effective, we published many flyers, posters, leaflets, primers, booklets of the nature, effects, and preparedness for lahars. We even had recommendations on what to do for people to be saved. Please note that in many countries, the civil defense would do this, but it was an agreed upon decision that since we had a very high credibility during the time because of the eruption, they tend to believe us right away on our suggestion. We had many briefings and meetings, one-on-one or group meetings to different stakeholders, but the role of the media, print, radio, and TV were very important. Now, After producing the hazard maps and doing awareness campaigns, our activities didn't stop at all because we need continuous monitoring of Lahar and its effects for continuing Lahar mapping and assessment. We need to document rapid changes in topography in the area affected by Lahars to determine areas to be immediately affected by future Lahars. I think all of you know that Lahar movement is like a windshield wiper. It goes this way or that way or that way. So we need to document that. And we had a bigger problem because we don't have a good support in the rapid topography mapping by the appropriate agency. So we have to go there and walk or fly. We need to document Lahar deposit volumes with time to assess potential volume of future Lahars in one river system so that appropriate planning and design of engineering interventions are done. And in terms of science, we need to camp out in the river channels during typhoons so that we can study active Lahars so that we can better assess the hazards of Lahars in the different drainages. Some of the products would be the deposit maps and reassessed Lahar and flood hazard maps. So by the end of 2002, like 11 years after, because of the continuous assessment, we lowered the risk for many areas in the southeast side, but we maintained the high risk of hazards for the western side because of the large amount of pyroclastic materials or even Lahars deposited at the middle slopes of the channel that can be remobilized during excessive rain. There are also many interesting geologic processes that we need to contend with. One is the formation of lakes due to Lahar Dam. For example, I've shown you the big river valley covered by pyroclastic flow, and this is the downstream part of it. Immediately after, several months after the eruption, Lahars flowing down the southwest slopes of the volcano blocked a river called Mapanwepe, and this became a lake. Upstream of that river is an active mine, but they stopped after the eruption, and because of the large amounts of water trapped by that Lahar Dam, it became a lake and flooded the roads exiting this community and affected many houses. So the plan was to dig a canal and drain it so that we don't store a lot of water and cause massive flooding further downstream, and that's what we did. Well, another very interesting thing is that if you have a very big crater produced during the eruption and you're in a tropical area, a possible crater lake breakout is a slowly developing threat. This is the caldera in June of 1991 and the caldera 5 years after. The caldera was slowly being filled with water. So by around 2001, we knew that the lowermost part of the crater called Maruunat Nuts is ready to be overtopped. And if this would be overtopped, there would be massive erosion of the 1991 and loose pre-1991 deposits above the bedrock of the Maruunat Nuts that can trigger massive, like 150 to 200 million cubic meters of lahars that would affect the communities further to the northwest. So the decision by the government would be to prevent a catastrophic lake breakout, we have to construct a canal to initiate erosion down to the Maruunat Nuts bedrock. And you cannot bring equipment there, but the decision was to just do it manually, lower the lake level by 5 meters, and if the slope gradient is appropriate, then it will trigger breaching through erosion. And so people were evacuated. What was the result? There was no breaching. The design gradient by the geologists were not followed by the engineers simply because, sorry if there are engineers here, but engineers in our country are trained to construct, not to destroy. So that's what they did. Instead of having a steeper gradient, they made it lower and nothing happened. But this prevented the accumulation of additional 15 million cubic meters volume of water, which will be very, very important during the rainy season. So the following year, A passing typhoon dumped a lot of rain in the area, and finally, that lower part was breached. Lake level was dropped by 23 meters, and this released 65 million cubic meters of water. With the bulking up of sediments eroded further downstream, a total of 160 million cubic meters of lahars was conveyed along the Buko River, and this is the area further downstream. The Lahar deposit did not overtop the dike protecting the villages, and nobody died. The lesser volume of water released and consequent lahars were due to the fact that we drained the canal. If we did not do that, then 15 million cubic meters of water times 3 would eventually be added on the 160. That would surely have caused overtopping of the dike and destroying a lot of villages and killing people. So what's up for Pinatubo in terms of the Lahar threat? The threat is still continuing, even 20 years after the eruption, through the following. Siltation on rivers would cause flooding that can overtop or destroy dikes that can have tremendous effect on communities outside the dike, because sometimes they feel that the dike gives them a sense of security. But now the river is higher than the surrounding. There is also a threat of lahars during extreme rainfall events. And the increased siltation would cause long-term flood problems in many areas of central parts of Luzon because of this siltation. So our problem is not finished yet. So what's the summary, and how do I summarize how we manage the lahar risks in Pinatubo? Of course, traditionally, we identify this and assess the hazards and the risks. We monitor the volcano and the lahar and forecast its activity through warning, through hazard maps, and then we communicate it. And we hope that people respond to the warning and do interventions. But sometimes uncertainties in our messages or in science would limit what we can say. But based on our experience, we don't worry about it. We just tell the people that there's a risk, and this is the scenario that we think, because of the magnitude of the problem. Many people were sensitive about the issue, especially for resettlement, because they don't want to lose their small property. And many Filipinos work in the Middle East, and they send money and build a beautiful house, and that's the only property that they have. So even though they know that they will be affected by lahars, they would not go. And sometimes people would downgrade the risk for lahars because, unlike escalating eruption, they don't see the lahar. It's not escalating, right? Unless their own area is being slowly encroached by lahar. So in essence, risk management of anything is actually can be divided into the science and technology dimension together with the human dimension and understanding of it. Sometimes these would clash, but we hope that the technology, science, and human dimension can work together so that people can be safer and would do the right thing with informed decision to be safer from these hazards. And to do this, scientists need to talk to people. We, together with the team of the civil defense, together with the team of local officials. I think if we just talk separately, this will not be very effective. And based on our experience at Pinatubo, both for the warning, for the eruption, and for the lahar, a teamwork approach is better appreciated by people on the ground, because if we are part of government, scientists from government, civil defense from government, officials from government, we sing different tunes, oh, they would say government is bad, right? So teamwork is very important. Okay, thank you very much.